Hello students, how are you guys doing? Today we're going to be going over lesson 6.12 and 6.13 at the same time. And we are going to basically learn how, let me get my highlighter, learning, here are your learning targets. So I can explain how the A and the C in the equation y equals ax squared plus bx plus c affect the graph of the equation. And you're going to be able to explain how the b in the equation y equals ax squared plus bx plus c affects the graph of the equation. And you're going to be able to match equations given in standard form and factor form with their graphs. Okay, so the first thing you guys are going to work on is your warm-up. And in order for you guys to do the warm-up, let me read it out for you. It says complete each row with the equivalent expression in standard form or factored form. So here they give you a standard form equation, just x squared. You're going to write this x squared and factored form. And then for this box, you are going to fill this out. And they give you the equation in factored form, and you need to write it in standard form. So right now, I'm going to give you an opportunity for you guys to answer x squared. Go ahead and do that now. All right, awesome. So now that you guys tried this, x squared in factor form is basically just x times x. All right, so now go ahead and type in your answer for standard form. Given the factor form equation, x parentheses x plus 9. Go ahead and type in your answer now. All right, cool. So in order for you to convert a factored form into a standard form, you need to distribute this x, which is outside of the parentheses, to both of the terms inside the parentheses. So x times x is x squared, and then x times 9 equals 9x. All right, so now following this example, go ahead and type in your answer for x squared minus 18x here. All right, cool. So just by looking at this previous example, here we have x squared minus 18x. Just by looking at what we did, we know that in this situation, there has to be an x outside of the parentheses. Therefore, everything that was left over, so what would I have multiplied this x to get x squared? Well, that would be another x. And what does this term have to be so that when I distribute the x, I get negative 18x? Well, that's negative 18. And with that being said, I'm gonna just go ahead and do this one since I want to keep this presentation short. So we distribute the x here, and then we distribute the x here. So in this case, x times 6 is 6x, and x times x is equal to negative x squared. Notice in this equation, the x squared is negative. In these equations, the x squareds are positive. That's something that you guys have to be able to understand as we are working on these problems. Okay, so before we move on, I wanted to make sure that I went over a very important concept that I need everyone, or that we need everyone to make sure you guys understand, and that is functions and their graphs. We have learned three main functions so far in Algebra 1. We've talked about linear functions, we've talked about exponential functions, and we have talked about quadratic functions. This is basically what we're doing right now. So linear functions are just equations that are lines, and the general equation form would be y equals mx plus b. Exponential functions is what we learned before COVID-19, but those functions are y equals b to the power of x, and we are currently learning about y equals x squared. So the square is what makes the quadratic functions a quadratic. So it could be written in this form here, or it can be mostly recognized in this form here, where we have ax squared plus bx plus c. Now the graphs of linear functions make lines. The graphs of exponential functions make these exponential graphs here. I like to call these the Superman ride graphs. And what you guys have been learning are the graphs of quadratic functions, which are called parabolas. Okay, so parabolas is the name of the graph, which looks like a U shape figure, and these parabolas are the graphs of quadratics. So now that and this is basically what we're focusing on today. So now that I went over this, let's go ahead and figure out what they're asking us to do here. So using graphing technology, you're going to have to graph y equals x squared, but we already know that y equals x squared is basically this graph here. Okay, and then it says, and then experiment with each of the following changes to the function. Record your observations. So what they want us to do is they want us to use graphing technology to be able to determine. So step number one, how does adding different constants terms to x squared affect this graph? In other words, y equals x squared is this parabola here. This is y equals x squared. So what they're saying is, how would x squared plus 5 change this graph? So and then same thing, how does x squared plus 10 and how does x squared minus 3? So right now you're going to get a chance to answer this question. So the question is, what do you think is going to happen if I were to add either a 5 or a 10 or subtract the 3? What's going to happen to this graph? Go ahead and write your answer now. All right, cool. So now that you had a chance to answer what would happen, well, the reason why I started off the way I started off is because now I want to show you guys how to use graphing technology. So what I want, these are my nephews, and this is my baby. Anyways, so what you guys are gonna have to do is you're gonna have to open up um, internet page. So as your hopefully, I don't think you'll be able to, yeah, I think you could be able to do this, but you're gonna have to open up an internet page. You're gonna go to Desmos.com. Once you have Desmos.com, you are going to start graphing. And we're gonna do, basically, we're gonna graph this equation here first. So the way you graph it is you press x to the power of 2 plus 5. Okay, so if you can see the equation over here, okay, this is our original equation, y equals x squared, and this is our equation, x squared plus 5. What do you notice happened to this equation after we add, well, actually, what happens to this equation after we added the 5? So if you notice that this original equation, y equals x squared, starts here at 0, 0. And it starts here at 0, 0. And if you look over here, the equation does not start at 0, 0. It starts at 0, 5. Now, if I were to type in the second equation, let's go ahead and say we don't want that right now. X squared plus 10. What happens to this equation? Oops. X squared plus 10. What happens to this equation? Well, the original y equals x squared started at 0, 0. This one's starting at 0, 10. Okay, and now let's go ahead and type in the last one. X squared minus 3. Now what happens to this equation? So the original y equals x squared started at 0, 0, and this one starts at 0, negative 3. So what can we say about adding a constant? Basically, this is a c term to the x squared. So what we can say to this is basically, I want to insert. What we can say to this is the c term is going to move the graph. So it's going to shift the graph either up or down, depending on if it's a positive or it's a negative. So notice that this plus 5 made the graph, instead of starting at 0, 0, it made the graph go up 5. And this minus 3 made the graph go down 3. Okay, so now that we went ahead and we answered question 1, now you guys go ahead and try to see if you can answer question number 2. Multiplying x squared by different positive coefficients greater than 1. So what do you think is going to happen to this equation, y equals x squared, if I multiply the x squared by either a 3 or a 7.5? Go ahead and put your answer now. All right, so now that you guys had a chance to see if you can answer this question, let's go ahead and type in what would it look like if we added a 3 in front of the x squared. So I'm going to say y equals 3x to the power of 2. And what just happened? So this is our original. As a matter of fact, I'm going to type in our original equation here, x squared. So y equals x squared is our purplish blue graph here. This is the original. And in the first one, we typed in y equals 3x. So what happened from the original to the new one? Now, what would happen if I were to type in y equals 7.5x to the power of 2? Now, 7.5x to the second power is the black graph. So notice that we have our original equation, x squared, but when I added a 3 in front of the x squared, or I shouldn't say added, I should say when I multiplied the x squared times 3, what happens? All right, and then when I multiply that now by, instead of by 3, now by 7.5, what happens to the graph? So the graph in this situation gets, you can say skinnier, but we like to say it becomes more narrow. Or you could even say skinnier. I think I misspelled skinnier. So it becomes skinnier. All right. So now that we've talked about the constant being added or subtracted, that makes the graph go up or down. And now we talked about the a value, the number in front of the x squared. If it's a big number, it makes it skinnier or narrow. Now, what do you think is going to happen to this equation or to this graph if I multiply the x squared by a negative number? So multiplying x squared by a different negative coefficient less than -1. So go ahead and type in what you think is going to happen when you multiply by -1 now. All right, awesome. So now that you had a chance to do that, let's go ahead and figure it out. So let's keep this equation here because that's the original. So let's type in here. So y equals -x squared. Oh, and what do you see here? The graph basically went down. All right, and if I were to type in the second equation, not only is the graph, well, we just learned that if we multiply the x squared by a number greater than 1, it's going to get narrow or more skinnier. If I multiply by a -4, oops, a -4, our graph, and this is a blue one, our graph not only did it go downward, but it also got skinnier because of that form. So in this case, if I multiply by a number that's a negative coefficient, the graph is going to go downward. In other words, it's facing down like that. All right. And now, this is almost kind of the opposite of number 2. Question number 4 says multiplying the x squared by different coefficients between -1 and 1. -1 between -1 and 1 basically means 0 point something. Okay, so like 1/2 is the same thing as 0.5x squared. And then -0.25x squared. So go ahead and type in what you think is going to happen if we multiply the x squared by a different coefficient between -1 and 1. Go ahead and type in your answer now. All right, so now that you guys had a chance to do that, let's go ahead and see what happens. So if I were to make this 1/2 x to the power of 2, forgot the y equals. So y equals, check it out. So x squared is this regular purple graph here, but when I type in 1/2 x squared, what happens here? That's the green graph. So it still starts at 0, 0 because I didn't add a constant like I did over here. But what happens is that this graph now just got wider. Okay, now let me go ahead and put, well, first of all, in this situation, the negative is going to make the graph go down, But what's going to happen with the 0.25? So y equals negative 0.25 x to the power of 2. So because 0.25 is a number less than 1/2, so 0.25 is less than 0.5, it's going to be even more wider. Okay, and because of the negative, it's now going downward. So in this case, the decimal between -1 and 1 is gonna make the graph get wider. Okay, so with that being said, let me go ahead and open this back up to PowerPoint. Let me now talk about this slide here. So after I'm done going over this slide, I really recommend you guys write this in your notebook or in your notes or somewhere so that you have it as a reference, because this is very important for you guys to remember. So yes, I wrote, you should pause the video and write this down in your notes after I'm done going over it. So quadratic functions in this form where we have y equals ax squared plus c. So the ax squared plus the c, the term a is in front of the x squared, the c is a constant. So whenever you have the a term, if a is a number bigger than 1, it makes the parabola, which is a graph, get skinnier. Okay? If a is a number between 0 and 1, it makes the parabola wider. And finally, if a is a negative number, it makes the parabola open downward. Okay? That's all of the effects of the a term in terms of if the number is bigger than 1, if it's between 0 and 1, if it's a negative number. Now let's talk about c. So c affects the graph in two ways. If the c is a positive number like +5, it makes the parabola go up 5. So instead of starting at 0, 0, it's going to start at 0, 5. If the c is a negative number, let's say this was -3, it's going to shift the parabola down. It doesn't make the parabola a negative. What happens is that the parabola, instead of starting at 0, 0, it's going to go 1, 2, 3, and then at this point, the parabola is going to go upward in this direction. Okay? So that's basically what this is saying. So if the c value is negative, it shifts the entire parabola down. Okay, so my recommendation is for you to pause the video now, copy this in a notebook, and then have it in your notes for future reference. We're continuing. So now that we talked about the A and the C term, so we just talked about the A and the C term, now we're going to talk about the B term. So the B term, if you remember, y equals the general standard form quadratic equation, ax squared plus bx plus c. Okay, well, right now we're going to talk about the B term. So it says, using graphic technology, so we're going to continue using Desmos. It says graph y equals x squared, which we already know, and then experiment with adding different linear terms. So we're going to start with the first one here. All right, so in order for me to do that, I need to get out of PowerPoint, make this smaller, and I have my Desmos graph here. Okay, so let me go ahead and erase these two. I'm going to keep this. So this is the regular y equals x squared. Okay, that's our original. And now they want us to add a plus 4x. So let's go ahead and do that. So y equals x squared plus 4x. Okay, so if you notice, something happened to the graph. It doesn't start at 0, 0 anymore. This new graph, the one in black, now starts at -2, 4. -2, -4. But that's not the crazy part about this equation. Okay, so let me go ahead and show you this equation again. Y equals x squared plus 4x. The new graph, the new parabola is going through this point right here, through these, this is an example of that graph. Now let me go ahead and type in, let me get rid of this for now, type in the next one. So y equals x squared plus 20x. Okay, you can't see this graph because it is a big graph. So let me zoom out. So here is the zoomed out version of this graph. So I want you to notice what's happening to this graph. Okay, so where did this graph start now? So instead of starting at 0, 0, this graph is starting at -10, -100, And look at, ooh, I forgot to mention, look where it's crossing the x-axis. It's crossing at -20, comma 0, and it's crossing at 0, 0. Actually, I didn't even mention the first one. This one, x squared plus 4x, is crossing the graph at -4, comma 0, and at 0, 0. Interesting. Okay, so now we're going to write down the last one. Y equals x squared minus 50x. And this graph is even bigger, so let me go ahead and make this graph zoom out more. And what do you guys notice now? Let's see, let's do this. Oops. Right about there. So what do you guys notice now? So the graph is crossing at 0, 0 and at 50, comma 0. So, and if you look at the equation, y equals x squared plus 50x. So right now what I want you to do is you're going to answer the question. And here's the question. The question is, what do you think the b term is helping us, or what does it help us with in terms of the graph? So the question one more time is, what do you think adding the b term to the x squared will help us in terms of the graph? Go ahead and answer your question now. All right, welcome back. So if you answered that the b term is helping us find where the graph crosses the x-axis, you are correct. So in this case, this graph here, which is the x squared minus 20x, we have our x-intercepts at -20 and 0. For this one, we have our x-intercepts. You can't really tell because of how zoomed in it is, but let me go ahead and move these out a little bit more. I'll come back to the other one, but the black one is crossing basically at -4, comma 0 and 0, 0, and then this one here, as we saw earlier, is crossing at 50. Okay, so now that I went over this, now we're going to have to, based off of this observation, we're going to have to answer this question here. So it says, use your observations to help you complete the table without graphing the equations. So go ahead and based off of what we just talked about, what would be our x-intercepts for y equals x squared plus 6x? Go ahead and answer that question now. Okay, cool. So now that you got a chance to answer this one, let me go ahead and go over it with you. So we learned that this equation will give us -6, comma 0 and 0, comma 0. Okay, and same thing for the second one. We'll talk about the x-coordinate of the vertex in a bit. So now the second one, y equals x squared minus 10x. Go ahead and figure out what this will become. Okay, so now that you had an opportunity to do that, the x-intercepts for this equation would be +10, comma 0 and 0, comma 0. So what do you notice? So in the warm-up, we talked about this equation being in standard form and us having to convert it into factor form. We'll remember, if you remember correctly, the factor form in this situation would be an x outside of the parentheses, an x plus 6. Okay, and in this situation, for example, we have an x outside the parentheses and it'll be x minus 10. Now, what do you notice about our x-intercepts? Well, in this case, this x will be the x-intercept of 0, 0, and this positive x plus 6 will give us the x-intercept of -6, comma 0. And if you notice here, this x will give us the x-intercept of 0, 0, and this x minus 10 will give us the x-intercept of 10, comma 0. If you haven't noticed already, but basically, once we have it in factored form, all you have to do is flip the sign of the number inside of the parentheses, and once you do that, that would give you your x-intercepts. Okay, so now that I went over those two, now let's talk about the x coordinate of the vertex. So I'm only going to focus on the first two just because of time. So we have our equation y equals x squared plus 6x. Okay. And then we have, okay, so let's do this one first. We know our x-intercepts are basically -6 comma 0, and 0, 0. So if we know our x-intercepts is -6 comma 0 and 0, 0, what the second part of the problem is asking you guys to do is to find the x coordinate of the vertex. Well, this point right here is your vertex, -3 comma 9. But what can you tell in terms of the x-intercepts and your vertex? Well, if you count towards the middle of the x-intercepts, we end up getting the x value of the vertex. So between 0 and -6, the middle of that would be -3, and that would be our x-intercept. So in this case, we were right. Our x coordinate of the vertex would be x is equal to -3. Now, let's try to see if that's actually true using our second example. So x squared minus 10x. So minus 10x is right here. So because it's a -10x, we change the sign to a +10. Now, if our coordinates of our x-intercepts is 0, 0, and 0, 0, and 10, comma 0, then what's in between? If I were to count to the middle, between 0 and 10, the middle will be 5. And is that where the vertex is located? Yes, it is. So we would have x is equal to 5. Basically, the number in between my x-intercepts. Okay? So now that we talked about this, we can basically figure out in terms of our equations. Let's go ahead and work this one out now. So y is equal to, whoops, here we go. So y is, I'm doing the third one here. So y is equal to -x squared plus 50x. So in this case, I want to make this into factored form. So I'm going to leave the x outside, where since this is a negative, it stays -x plus 50. Now, in this situation, because we have two negatives inside of the parentheses, we don't just change it into a negative, we actually have to factor it out or solve it. In other words, we make this equal to 0. We have -x minus 50 is equal to 0. We add 50 to both sides of the equation. We get -x is equal to 50. And then when we divide both sides by negative and invisible 1 in front of the x, the negatives go away, and then we're left with -50. Okay, so in this case, our x-intercepts would be 0, 0 because of that x here, and it'll be -50, 0. Those would be our x-intercepts, 0, 0, and -50, 0. And now, what number would be the x coordinate of the vertex? Well, we know that if the x-intercepts would be 0, 0, and -50, 0, 0, what's in between -50 and 0? That'll be -25. Okay, so then that's basically how you find the x coordinate of the vertex. So basically, once I'm done with this part, I really recommend you guys taking notes on this. So again, quadratic functions, but now we have the b term in our quadratic function. So the thing that you need to do from here is convert this to factored form by making the x go outside of the parentheses. Basically, we're undoing multiplication. So if I wanted to go from factor to standard, I would have to distribute the x, and that's how to get this. But it says to find the x-intercepts, make the equation into factor form, so go from standard form to factor form, change the sign of the factor in the parentheses, and then your x-intercepts will be always 0, 0 because of this x outside the parentheses, and whatever this is with the sign change. Okay, and then to find the x-coordinate of the vertex, remember that the vertex is the lowest point. You basically count to the center between the two x-intercepts. All right, so let me go ahead and just show that one more time on the graph. So if you have x squared minus 10x, for example, the center would be 0 and positive 10 because you always do the opposite sign, positive 10. And to find the vertex, you have to basically count to the middle. And the middle in this case would be 5. Okay? All right, so that was a little bit longer than normal, but there's a lot of information to go over. So now that we have done this, go ahead and go back to Schoology, start working on your cool down, and good luck. If you have any questions, email your teachers. If not, take care, and hopefully we'll see you guys soon. Stay safe and do your cool down. Have a great day.